Now this is recording. RTI
International
Center for
Forensic
Science
presents
Just Science.
Welcome to Just Science, a podcast for forensic science professionals and anyone who is interested in learning more about how real crime laboratories work. In this special release season, Just Science will be covering presenters at the National Institute of Justice's Research and Development Symposium held in conjunction with the American Academy of Forensic Sciences annual meeting in New Orleans, Louisiana in February of 2017. In this first episode, funded by NIJ's Forensic Technology Center of Excellence, we interviewed Dr. Jarrad Wagner from Oklahoma State University. This NIJ-funded research is striving to make law enforcement officials and their communities safer by determining practical ways to detect methamphetamine clandestine laboratories through water waste systems. Here's your host, Dr. John Morgan.
Welcome to this edition of the Just Science podcast. Today we're at the American Academy of Forensic Science meeting in New Orleans, where we're going to be talking to a number of different folks. Today's podcast is with the former G-Man and now Oklahoma State researcher, Jarrad Wagner. Jarrad, welcome to the podcast.
Thank you very much.
So, Jarrad, you actually have presented earlier this week at the NIJ Research Symposium. So, Jarrad, what you looked at was what you call one-pot methamphetamine production. So, can you tell me, why are you interested in methamphetamine clan lab work in general?
I've been involved in clandestine laboratories for a long time as a forensic scientist doing investigations, and I think G-Man might be reserved for special agents, I'm not sure.
It's okay, you were with the FBI laboratory in
yeah.
the tox section. You're a toxicologist, right?
I am a toxicologist. When I was with the Bureau, I was in a lab response team. So we would go and collect the evidence and get it to the labs, and we'd work with consortiums to get it to the right place for the right analysis. Because some of the stuff we were working with was really, really dangerous. And I really enjoyed that work and kind of got me into thinking about signatures and things that we're going to use to try and track where these labs are. And I live in Oklahoma now, and we have had quite a lot of this type of lab. Some people call it shake and bake. It's also known as the one pot. There were some training videos from law enforcement side. We learned a lot about it starting in about '04. So we knew it existed, but no one had really taken the time to sit down, and that's what I really like about the NIJ and the forensic science mission. Hey, this is a gap. You can go to the NIJ, you can do a grant application, and you can get someone to help fund the work. And now I would try to do this anyway, but it takes time, a lot of time and effort to get these projects done, and there's a lot of moving pieces, so having something like that's important. So from the meth lab standpoint, we have lots of issues to worry about. One, we don't want people to abuse methamphetamine because it's a public health problem. We have to look at what are the sources of methamphetamine. One of the sources is import from other countries, and right now there's quite a high level coming in. It's being manufactured in other places and coming in here, so there is less of the type of lab that I'm doing research on. However, that lab is still prevalent. Drug production and drug abuse. What we see is if we regulate something, like we take away pseudoephedrine, they're going to find another way to make it. And you take away a solvent, or you take away
We've all
batteries.
seen Breaking Bad. We know how it works.
I haven't. I can't do it. It's like watching CSI. It just drives me nuts.
It's too fake, is that right? Is there such thing as blue meth, I have to ask you?
Well, I accidentally made some in this. It's a dye that they put in the camp fuel, and so when you pour it out, it's actually got a blue tint, and so the methamphetamine from that production did turn out blue, and so, yes, I know they made blue meth on Breaking Bad, but I don't know, it just didn't grab me. So I got through an episode and a half, and I was like, oh, no.
Because, because it's a story, not necessarily technically exactly right, of course.
So that's another aspect, is he used a couple different methods, and one of them involved phosphorus, and with the one pot, there's no red phosphorus involved, so we don't generate phosphines. I think there was a scene where he attacks people with some of the chemicals that are there.
That's right, yeah.
Realistically, from a public health perspective, so as law enforcement, I do a lot of training, both with DEA and other groups that are training first responders to clan labs. So because these officers are not just going to one lab, they're going to multiple labs. And while the labs aren't as prevalent as they were, say, in the late 2000s, I believe we were meth lab champions in Oklahoma then.
Sure.
They're not as prevalent, they're still taking place. And we find families living in the labs. There's chemical exposures. There's lots of groups that have started to do work to characterize what are the impacts on families and friends and the community from the lab. But we haven't done a really good job. We set cutoffs and limits, and you've worked in technology a long time.
Sure.
Sometimes we set limits based on what we can do. And sometimes we have a scientific rationale for what the limit is. Like when we do a wall wipe to determine how much methamphetamine residue is on the wall, or how much phosphorus, or what other solvents and chemicals. I don't know that we've done a really good job of making it rational. Different states have different rules that are enacted. There is not one place you can go and get all this information about how do I do this analysis in the first place? How do I, get the template, do the wipe, and know that, hey, I don't have meth here, or I have meth down to a safe level. How do we know when a house is clean? We have a law in Oklahoma that you have to report if your house has been used as a methamphetamine lab, and there's certain steps you have to take to remediate the house, or you're supposed to. Sure. So I think it can be an expensive proposition. Do you just need to remove the carpet? Do you need to change the drywall? What do you need to do? Do you just paint over things?
Yeah.
And I think you've heard stories about some toxic house type situations with people breaking out in hives and rashes. We're getting inhalation injuries, right? So I'm worried about public health. So if I'm worried about that, I'm worried about officer health. I know these officers are going into these labs and being exposed to these chemicals. And in this case, the one pot that I'm working with, it does use anhydrous ammonia, so ammonia gas, and that is very dangerous. Probably not as much ammonia as what you'd find in what we used to call the Nazi method or the birch reduction, but there is quite a bit. You worry about the health of the lungs of the people that are going back.
Yeah, it's actually pretty analogous to, I mentioned before we started that I was involved in chemical and biological weapons detection mitigation, and your approach to it is very familiar to me, to meth, because what you're doing is you're looking at signatures, right? You're trying to first understand, can you find this thing based on the signatures that it creates, which is very, very classic materials intelligence, MASINT is what they call it in DoD speak. But then there's also this whole issue of mitigation. When the Amerithrax happened, not too long after 9/11, remember very clearly EPA was supposed to go in and clean out, especially the Senate office buildings.
Yes.
And how do they know they were clean? What is it? It's a very important topic, and it's an issue that law enforcement is seeing on a constant basis out there with meth and other kinds of, well, I think it's probably more in opiates now too, I bet.
Yes, with the fentanyls that are coming in.
Maybe the cathinones and things like that.
I think fentanyls are more prevalent from this kind of health impact. We have an issue with fentanyl. It actually becomes a level A response. So for the listeners that aren't familiar, we have 4 levels of personal protective equipment or individual protective equipment, depending on where you live. And basically, level A is fully encapsulated suits with supplied air. Level B is you have a chemically protective suit on, but you're not fully encapsulated. So if there was a skin active compound, like fentanyl might be, and like some of the ammonia, chlorine gas, these things that can eat at your skin, you don't want to be exposed. So you'd want to be in level A. Most of the Clan Lab work that we do is in level B, which is I'm going to go take a sample, so I need to be in a respirator. And then we have level C, which instead of supplied air, it's filtered. So think of like a typical gas mask. And sometimes they're powered and things. That's great as long as you're not going to be in an environment that's oxygen deficient or something. And what you find as you go down the levels, your time on target increases. So level A, it's very difficult for me to do a long level A mission because I'm going to run out of air. And there have been groups, we have some very well-trained teams that look at rebreathers and those kinds of things so that they can go longer. But there's a certain stress level in the body that you can't manage to be in the suit for a very long time. And so we are providing training now because of the fentanyl issue. The DEA is providing training to groups, law enforcement, getting people trained up. Their partner training agencies are putting on these courses. We just participated in one in Oklahoma. We're trying to be forward thinking. So what's happening with the fentanyls are that people are buying this stuff and it's being imported, and then they'll mix it with binding agents. They're making fake opiate tablets. They're making fake oxycodone, fake hydrocodone, all kinds of stuff. So what that's going to do is it's a milling operation. So you get powders everywhere, and it's a little bit of the chem bio, and it's funny. Yeah. You don't really realize what you're absorbing when you're in that, not chemically absorbing, but knowledge absorbing. And you're right, the approach that I've taken to the meth problem is very similar to the approach I wanted to take with those other problems that we faced in the past. And what's neat about this project, so I work now with explosives and drugs and not the chem bio stuff. Why? Because I can get licensed for the things that I'm working on. So I have Schedule 1 through 5 DEA licensing, so I can work with controlled substances, and I have a pyrotechnics license and a blasting license, and we have everything up to code for ATF standards for storage and production. So I guess that's kind of how I fell into this research area. And it turns out that one-pot meth labs are a little bit dangerous, and we talked about, I said I did.
It's a shock to imagine, sure.
You're like, shouldn't they be really easy? Well, so they're not. They use different fuels that they put into this vessel. And then on top of that, you're gonna use lithium or sodium. Most of the labs use lithium. They take it out of batteries and things. But lithium has to be absorbed by ammonia in this reaction. And so that's what's neat about this research too, is that basically previously you would just put the lithium in the ammonia, pour your pseudo in, and you'd get your methamphetamine. It's not quite that simple, and no one on the podcast, try this at home, because that's not the goal here, but it's also pretty dangerous.
Well, lithium by itself is okay, but it can be very reactive.
It can, and especially with water, right? Even moisture in the air. And what these cooks do is they add water and sodium hydroxide to this fuel mix with the lithium. So a lot of the accidents that we're seeing in training and things that happen are from the flammability, because either they'll get starter fluid and pour it in, or they'll get cant fuel and pour it in, and it's just got a broad flammable range. And some of the safety issues and different things that we're seeing with the cook and characterizing it, we actually tried to look at multiple solvents. We looked at ether and we looked at cant fuel, but it solubilizes the lithium differently. It absorbs ammonia differently. So the reaction, it really changes the whole dynamic of the reaction. So it's not like you can just take one and then, just throw that in. And it got very complicated very quickly, because you don't realize all the changes. Just the change in humidity in the air, that'll change your lithium reactivity as you're going to put it into your cook. It'll change the whole way it runs.
People don't realize how much really cool chemistry is involved in some of this stuff. The one pot people, that's a fairly crude kind of approach generally.
Well, one of the other studies I've wanted to do is more of a social networking study, because in my opinion, based on talking to law enforcement and cooks, is that the recipes are being passed in jail or between friends verbally, so like an oral history. Sometimes they're written down, and we find these very odd nuances in each recipe, like, like turn around 3 times, and don't use acetone from Home Depot, make sure you get the Lowe's.
It's like alchemy.
It's a little odd, and so they don't always know what they're doing. I call that the ad hoc literature, so that's kind of historically, it's just like, okay, that's out there. But I'm kind of standing on the shoulders of giants a little bit. So like here this week with us, Harry Skinner and Terry Delcazon are both just amazing chemists, and we have an organization of Plan Lab investigating chemists. We work together to make sure we all stay safe and we can prosecute things successfully. We do research like this, or research has been done, and then we try and make sure we share the findings in a peer-reviewed fashion, but it's obviously a closed community a bit, because we don't want the information going anywhere. But they did work on other methods, so I can take the map of what they're doing. Also, the Australians have done a lot of really good work where they're characterizing, and also New Zealand. And so when you take that and look at the history of, the cook itself, so what I did was I applied that approach to the one pot, and we started doing yield studies, and that was in combination with DEA. First, we tried to just do it in PPE. So we wore chemically protective and fire protective SCBAs, and we went for a full day. We were doing one pots and just hot swapping with the bottles, right? So they just come up behind and change the bottle out. And it was an amazing research project, but in one day we got 7 cooks. A full day of everyone's time and effort, and in all the PPE, which is a drain. So I mentioned, going down range in a lot of hazmat gear is challenging. It's not a lot of hazmat gear, but it's exhausting. And you're in the suit, so you can't make notes like you want to. So at that point, I thought, I need to make this better. I need to find a way to do this safely in the laboratory. I have done a lot of hazard analysis on the cook itself. I'm going to try and do even a little bit more, because it's exciting and it can be very dangerous. So what we try and do is really eliminate the pressure hazards. What's happening with the cooks at their home, they call it burping the bottle, but it's basically, depressurizing it. So they might use a Gatorade bottle or a pop bottle. And so they take a pop bottle and they're doing the cook in it, and they'll shake it up, and they have to off-gas it so the pressure doesn't burst the vessel. The other thing that'll happen in these cooks is that the lithium that's in there, that's reacting with the water and trying to be absorbed into the ammonia, will actually melt into the side of the bottle, and then you get like a solvent jet coming out the side of the bottle that's on fire. So that can create a problem in your living room. So we actually did a study that I've just submitted. There's a new journal called the Journal of Forensic Chemistry, but we just submitted this article to them. And basically we did this study with ATF where we took these one pots, went to their burn lab, and we made duplicate tables, and we burned labs with ether, and we burned labs with Coleman, and we did short duration burns and long duration burns. And we're actually able to show that we could find remnants of the lab after a fire. The plastic kind of melts down around the sludge material, and so even after a fully engulfed really bad burn, we're able to find evidence of the actual lab itself. So the ATF did the accelerant analysis, because that's what they do, and we did the controlled substance analysis and produced the meth.
Now, this raises an interesting question because it reminds me of some of the work that's been going on in fire investigation in recent years, where fire investigation is basically looking at, residue, usually of VOC, volatile organic compounds of various sorts, and trying to infer from that, what was used as an accelerant in a particular case. And the issue with that is that it hasn't really gotten as quantitative as we would like.
Sure.
Right, and so
Well, it's hard to be quantitative
Yeah.
when you're being qualitative. So
Exactly.
what you're trying to do is prove the presence or absence of accelerants. And sometimes if you're in a garage, for instance, and there's a lawnmower and you prove the presence of gasoline, well, does that help you with your arson investigation? It's a little bit of a...
But you have a little bit easier situation because what they have to do is they have to set their threshold for a determination relatively high because of those uncertainties, right? Was it gasoline from the garage or was it something that was poured somewhere, right? But the residues you're seeing tend to be a little bit more unique, I would assume.
What was very interesting is the ATF was able to find ether in the ether cooks, and they were able to find camp fuel in the camp fuel cooks. And so that was great. And then, yes, we're looking specifically for methamphetamine or precursor. So we'll look for ephedrine or pseudoephedrine, which chemically they're the same molecular weight molecule, or just a different isomer, essentially, different chirality. So whether it's pseudoephedrine or ephedrine that they started with, we're looking for the precursor, we're looking for the product. And with this project, the first thing that we did was really focused on what's in here, what are we making, right? Because there are some byproducts that are very specific to the original cook process. So we've done research, Harry Skinner, Taylor Dalcazon, the DEA chemists that have come before, Tim McKibben, who was a DEA chemist, great guy, but we've done research on the birch method, and there's information out there about that. We had to take that and say, do we see similar things with this cook? Because it's done slightly differently, and there's a lot of chemistry happening in this one pot. So we were able to find an indicator compound. It's called CMP, which is cyclohexadienyl methylaminopropane, but we'll just call it CMP if you don't mind.
No, that's better. Thank you.
And basically what you have there is it just gets over-reduced on the ring. We're trying to remove an oxygen from pseudoephedrine to make meth. And so that's reducing it. So what happens is on the exposure to the electrons in solution, we call them solvated electrons, we actually can affect the ring structure of methamphetamine instead of pseudo, and instead of just affecting that one oxygen molecule we're trying to remove. So we did find CMP.
Is CMP also psychoactive, or is it just...
We don't know that, but we do know it's found toxicologically. So if we have people in a community that are using one pots or doing the birch reduction method, we'll find CMP that's coming out biologically through elimination. So we will find it in urine, we will find it in their system. I was talking with a colleague here this week, and I was kind of talking to him about the project, and he was saying, yeah, we used to get that a lot in our toxicology cases up to about 3 years ago, and we haven't really been seeing it, which makes total sense from my perspective because of the large influx of methamphetamine, usually from the south, but that comes into the country. There's no sense in making it. It's just easier to buy it. And it doesn't have CMP because they're using large-scale production methods. They'll just use a different method.
So it just doesn't have CMP or other byproducts of that sort in it?
It'll have other byproducts, but because it's a different reaction. And like the signatures work that the Australians do, they have a lot of hypophosphorus methods over there. They have different signature compounds than what I'm looking for with this. But no one had really characterized the signature compounds here. So I think that was the biggest thing. And so we wanted to just look at the sewage. We know these cooks are happening. We wanted to know what is the impact on the public health through the wastewater stream. From my perspective, though, it was not just that. It was, could I go to a source and sample and actually follow a trail of increasing concentration to a source? So we don't know that this neighborhood has any sort of lab in it, but we did a water sample, and wow, we found something that indicates a one-pot laboratory, and it's pretty high, and we're seeing it quite frequently.
Yeah, I mean, if you're seeing CMP, you're not going to see it anywhere else. Even ephedrine or a pseudoephedrine is going to be relatively unique, right?
Well, it could be. So in our proof of concept study that I talked about this week in the symposium, we were able to demonstrate the detection. We worked with the city, and we worked with an actual lift station and in the wastewater system. I show a picture in the slideshow, so if you guys go to the landing page and you click on the talk and just ignore all the jokes and just pay attention to the science, but there's a picture of the cistern, and I show my sampling device, and basically we used a long set of tubing, and it's a pulse sampler. So it pulls up water. We were able to program it so we could sample every 15 minutes for 2 days, and you could program it how you like. you had to go pretty deep into the cistern, and these are large volumes of water that we're dealing with, and they can get clogged. So I did learn that wastewater is biphasic. There's solids and liquids together, and that solids can clog these sampling devices. So we did see it a little bit, but we didn't, like you were telling me a little bit, that you were able to go into the pipes.
Yeah, we actually were sampling at the Nevada test site at some of the abandoned little towns that were built on the Nevada test site back in the 50s and 60s. And so the advantage in some respects from the sheer disgustingness aspect was that those were relatively abandoned. So although we had active work going on in the little town at the time, wasn't nearly as extreme as it would be going into an actual living city. And I would say that your sampling system was way more efficient than ours. Our sampling system was me as a grad student climbing down in there.
And in the past I had worked with EPA, and they had water sampling things for streams and things like that. So they had these kits that they would send out, and then you could get them distributed to the right labs to make sure the water was safe. And there is something to be said for simple, right? And when I was saying we're going to be doing some sampling at different ports, and they'll just collect a liter of water, cap it, and bring it in for our analysis. But it's interesting what we found, like we talked about the biphasic nature, and it's kind of dirty, and do you want to crawl in there? There's height hazards and things. You don't want to fall into the through the manhole cover, and there's ladders and different things. But I have graduate students that work with us on this project, and they did most of the work. So my job is to make sure I can guide them in the process. It's not simple to do the production, and it's definitely not simple to develop the methods to detect the different drugs we're looking for in signature compounds. So the first thing we did was really focus on characterizing these cooks, and we had some great access to talent at Savannah River. We were working with them on the project, and they were able to do some things we hadn't done before. They did some electron microscopy, some SEM of the actual sludge to look and see what's in there. Now we kind of knew, hey, it's ammonium nitrate reacting with sodium hydroxide, it's going to generate ammonia in water. Okay, but to actually get them to show the sodium nitrate crystals and things. And then, of course, there's pseudoephedrine that's still left in there. They did some GCMS work for us. At OSU, we do a lot of work in clan labs, and I've talked to people that have been involved in the methamphetamine profiling program at the DEA, and hey, what are your experiences? If you take a solid methamphetamine hydrochloride, what do you need to do to characterize that and determine how it was made? Or are you doing isotopic analysis? What exactly are you doing? So normally in my research, I do not produce the final product. I just prefer not to. When I do, then we have a controlled substance that we have to secure, and then we have to work with our local law enforcement agencies to get rid of it when we're done with the study.
And there's a lot of regulatory burden.
Yes,
definitely.
Right. But in this case, because we wanted to know what would happen if they were cooking in their house and they manufactured methamphetamine, what's left behind? And so that was really tricky for us because that meant we had to salt out. Now the cooks will actually use an improvised salting procedure. So we call it salting out, but basically when in the production process, the methamphetamine, it's actually volatile. It'll float right out of solution. It'll be airborne. In the camp fuel or solvent, whatever is there, that methamphetamine is soluble in it, and it's just sitting in there. So what you want to do is you have to separate that camp fuel or ether, whatever starting fluid, whatever you're using. You have to separate that from the sludge, and then you want to purify the methamphetamine. And the way that's done is that the methamphetamine salt is not soluble in that solvent anymore. It's water soluble. So what's typically done is they'll mix two reagents together and generate an acid gas and just float it around in the solution, and then you see the methamphetamine precipitate out, and we call it salting out. I think the cooks have other terms for it, but then you just filter that out. So we did that because and that's when we accidentally made the blue meth the one time, or 3 times. So we did 3 of each type, and then filtered out that methamphetamine hydrochloride. Now what's really interesting here too is that, with extractions, it's like what we say, it's like 90%, right? So if any of you young chemistry students are wondering why you're learning Le Chatelier's principle, it's really kind of important, and you use it so much in chemistry. You're not always going to get 100% of what you're looking for. So you do an extraction or you do a precipitation, and these guys have, and gals probably, they're acid generators, or some of them are more humid than others. If it's wet, you make a really snotty product. It's not, so there's a lot of variation. How do you know you got all of it? And you didn't. So, some of them might be extracting multiple times. I don't know. We extracted once. We tried to be very consistent in the way we were salting. And instead of using a gas generator, which we could have, we chose to use a small lecture bottle that we got. And that was the thing too, is while we can use street type chemicals, when we're trying to determine source terms, we're going to start with these laboratory grade reagents first. And that's also better for safety. There are impurities that are in these products because they're not made to manufacture meth. And so there's things in there that are not really safe. So
I'm always trying to convey that the way in which you do science, you have to start from what you can control and then move out from there. And that's how you build knowledge. You can't use the stuff from the street if you're going to do these, at least not straight out.
So we salted out the meth, but it turns out that it wasn't visible, but in the solvent, which they don't need anymore. So if they pour that out, am I going to be able to detect the impurities in it? And so it turns out the answer is yes. So we did these productions, we salted it out, and then over 3 days, these were deposited, and then we monitored the water downstream. First we used dye. We wanted to get an idea of the flow rate that was in this wastewater system, and it does vary. So as people use the restroom on our little wastewater line, we would see increases in flow or decreases. And over time, when that cistern fills with water, it pumps back out. So what we did is we knew when we made the deposit, we knew how far away it was, we watched for the dye to come down. We'd start sampling before and continue sampling over 24 hours. And what we found is we found really nice curves that showed an increase in the level of chemicals we were looking for, followed by a decrease.
Over both minutes and hours, right? I mean, you were seeing stuff even hours after.
Yes, and that makes sense. So think about your Nevada test site experience. So you have these solids that are in there, and sometimes they're called flocculates. There's other phrasing and stuff, but basically the pipes are not clean. And so your material, the Chatelier's principle, it's going to be in the liquid, it's going to be in the solid, it's going to migrate between both depending on where it wants to be at that moment. Is it water soluble or not? And then you've got a solvent going by pulling stuff as well. It did do what we expected. You know, you do the deposit, and then over time, it didn't like vanish right away. It was over time we were able to see it go up and then go down. But the baseline went up just slightly on the 3 successive days. And then we waited a week. So we did all of the starting fluid cooks first, and then we did all of the camp fuel cooks after.
Sure. I think that one of the key things that we want to have takeaway here is, like, to what extent can law enforcement and the crime labs use the research that you've produced? So what would you recommend people do with respect to the use of the research findings at this point, and the best way to kind of reference them and get the bottom line from a pure practice perspective?
I think it's going to be interesting to see. It was a lot of work to develop and validate the method. We did solid phase extraction with liquid chromatography and tandem mass spectrometry, and so we call that LC-MS-MS, but it's kind of an expensive tool.
There's a lot of LC-MS-MS now in crime labs, I think, though. I think it's emerging, definitely.
Right, and RTI has been actually very formative in helping get that accepted into the industry as well. So we're seeing it more often, but not every lab has it. We were able to be successful with the method we initially developed at I would say somewhat reasonably sensitive, but not sensitive for wastewater analysis. So wastewater analysis, they're looking to get to nanograms per liter or so. And we were at about nanograms per mil. Now it turned out with the simulations that we performed, we were able to see what we needed. So that was great.
Yeah, you're in part per millions, right? Basically is what that is. Yeah.
But we wanted to be at parts per billion. And we've now redone the method, and we're in the process of revalidation now. And now we're going to go to these sampling sites around town and get samples and see what we see, and see if we're seeing production indications anywhere. And the other thing is, that's a challenge for this, is that there is methamphetamine in the population being used. The methamphetamine that we detect, the pseudoephedrine that we detect, I mean, if someone has a cold, they're taking Sudafed, and they're going to eliminate that through their urine, and that's going to go in the wastewater stream. I think the real problem for us is going to be able to distinguish between what is a biological origin that's been processed by a user versus what's a lab. The goal starting this work was, can we track a signature and can we identify the location of a laboratory? So I think that the answer is yes, we probably can, but we're just now in the phase we're going to be seeing if we can discern background versus lab. And then what's the right sampling time? So the answer is, to get anything into practice in the community, it's got to have utility. So we're really trying to demonstrate utility. But the other thing is, for court systems, this might be a great tool to get probable cause for a warrant, and then go that route. But it takes a little bit of effort to do that. And even the arson stuff we did, the work we were looking at burning labs to show that it is in fact controlled substances that caused that fire, the production of methamphetamine caused that fire, you know, that's not been widely adopted yet. We're trying to get the word out that you can do it, but then labs are going to have to develop their method for how are they going to get what they normally think of as an accelerant or arson analysis. Now they need to change their thinking and look at it and, can I find controlled substances in this? we're really working hard, and I know the NIJ is helping, and I know RTI is helping as a center of excellence, but we're really trying to, as an industry, just across the board, support the science that we're doing. And we're trying to not do pseudoscience. The conclusions we draw, we want to be accurate. It's really important. So chemistry, we're in a unique position in chemistry because it is so strong. And we can point to mass spectrometers, and we can point to these things. As you get better and better at what you do, you have to make sure that you can derive the meaning from those statements. And then, so from a scientist perspective, I can say, oh, I know what I think that means, and I can publish that. Well, an attorney is going to feel very differently about that same information, or they might ask a question in a different way, and they might have a different interpretation.
Well, yeah, I think, to some extent, one of the things that we've seen over, let's just say, a century of forensic science practice is you have, well, I saw this thing at a crime scene. And it can be anything from a piece of pattern evidence to some sort of chemistry or whatever else it might be. And there's a certain common sense aspect to it, right? If I see methamphetamine, something's going on there with somebody who is using methamphetamine or making it or something of that nature. And you have to have that in law enforcement because it's the real world. Not every crime scene is an experiment.
Right.
And then the next level of that is to take much more of a phenomenological point of view. I'm trying to understand kind of how things might occur in a real world situation that produce it. And you're actually even going beyond that, I think. You're actually, looking at the fundamentals, and as I was saying, the signatures, the material signatures that are produced, and trying to understand that from a really fundamental chemistry perspective. Because once you understand that, you really can go to all those other levels immediately, because those give you a fundamental basis on which you can make conclusions about almost any site once you understand the science better.
And I kind of like the idea of force multiplying. I mean, it's nice to have a niche. It's nice that we could do this, and it's funded work and it's important, but getting those other experts in material sciences that can see things that, oh, did you think about, no, I hadn't thought about using that approach. But when we come to a meeting like this and you get to interact with your peers and from all different groups, and when they come and they ask questions, and it was really, I had some DNA people that were at the talk.
I heard that you had a very entertaining talk, and even DNA people enjoyed hearing some talks work. We're all one big happy forensics family.
We are, and DNA does not get all the money, so totally other people sometimes get funding too. So it is nice, but I think it'll get accepted, but I think it is doing things like this. It's doing podcasts, and it's talking about the work, and then having scientists that are in the labs, but I'm still just kind of that researcher guy. I'm an OSU professor, and I'm not the practitioner in the crime lab. We happen to share a building with our crime lab in the city of Tulsa, but you still have to get buy-in from the forensic scientists, and that's what's neat here at this meeting is we have practitioners here that are also interested in research, so that when they'll see what I'm doing, they're like, oh, that wouldn't be that hard to do. We could apply that. But I think down the road, the other way that we get the information out is I'm going to call out the Center of Excellence. So you guys just published a great review on evidential breath, looking at roadside use of handheld breath instruments for evidential purposes in DUI. And it was called a landscape study, I believe.
Yes, that's right.
So when this gets mature enough, I would depend on you guys to help me in your organization to help and NIJ to help that, hey Jarrad, this was great, we funded some basic R&D, but we think there might be some ways to put this into practice. And that kind of study where you look at, okay, we're doing it in multiple areas, what's been the outcome? And I think when you put all that information together, sometimes the science is more mature than you realized. So, and that's what I thought was really elegant about the landscape study. And I'm actually using it in some of my coursework with my students. I'm having them go through it and trying to build that kind of model for other systems because I think it's such an important approach. But until we build a consensus that, hey, this is acceptable and this makes sense, I would add one caveat, even though it didn't reference my work. There was an article and it was talking about how Big Brother is watching and they're doing all this wastewater sampling and they're going to know all your habits. They're trying to violate your privacy and that was definitely never the intent of this work. The intent of this work is we're really worried about the public health impacts of these labs. We're worried about the officer safety. We don't want people to be cooking with these labs because they really cause damage to themselves and others. And so if we feel like this is one tool we can use in wastewater to track back to a source. So I mentioned we're doing other sampling now. The other thing we're doing is we're looking at airborne effluents now. And so the second phase, kind of the second and third phase, is to see if we can detect the effluents coming off of a house. The same way you might use infrared to look at, okay, there's a lot of heat there, are they growing marijuana or something like that. And it'll be very nice if we can do it. It's just much harder, and you mentioned before we were on air, you talked about some of the portable mass spec work that you had done.
Sure, yeah.
that really is the direction I want to go. There's some companies that have developed ambient mass specs that are handheld and very small. I'm hoping to get one of those companies to be interested in letting us try the instrument and see what we can detect, because eventually...
Because I was thinking maybe you would do some sort of standoff infrared or something like that, but
yeah,
depends on what signatures there are, too.
No, and that's exactly right. It's the airborne, so we know there's going to be ammonia. We know there should be some acid processes. We don't know how long we're going to see it, right? We know there's methamphetamine, and we know it volatilizes. The same thing with the pseudoephedrine, because you make the free base when you're doing this process. So what I would love is to have an officer or just someone that is investigating the lab. It would be really nice if they can, in real time, detect what's happening in the building and know that, hey, there's a lab taking place. What my suspicion is, as a chemist that's kind of been working on these problems for a while, I think we're going to have to go to some sort of a portable sample collector that captures things like on a solid matrix. So I'm thinking like sort of like SPEME, but maybe not SPEME exactly, but so, and for the audience, SPEME is
solid phase microextraction.
Solid phase microextraction, right? And so we use SPE, which is solid phase extraction, but so it's not as small, I guess. But to actually take some of those types of fibers and pull through, do some sampling, and then bring it back and use the same techniques we're using now. So extract the fiber following, did we detect it? The problem with that is you don't get a real-time analysis. You don't know right there at the scene. And so the analogy, we mentioned the landscape paper, it's really nice to be at the side of the road with the breath device that tells you you're an 09, you're not able to drive, and this is what I need for court, and we're going to move forward. It's nice to have that at the scene. Sometimes they don't have that, or they refuse that test, and so now we have to draw blood. And so sometimes they refuse blood, and then you have to get a warrant. Whatever the case, they now have, I did all these tests in the field, I know this person appeared impaired, I'm waiting for the blood result from the lab. So I think it's workable, but it would be so nice to just have that tool that we could use right at the labs to detect it real time.
Sure.
But I'm sort of the opinion that we're going to have some kind of sampling device that we bring back then to the lab following the sampling and say, did we detect anything of what we suspected?
Well, all that sounds really exciting. It sounds like you certainly have. Now, is your NIJ grant continuing at this point, or?
Yes, it's in phase 2 right now, which is so the first phase was to do all the source term characterization, which we talked about, and that's what I presented this week. And then we just did the proof of concept. Would we be able to see it possibly if someone did a dump? Because we really didn't know. I mean, I was hopeful, but I wasn't sure. So now we're, from the wastewater perspective, just to wrap up that portion of the project, we're Savannah River, who's our research partners on this. We're going to get some samples from the area, we're going to get some samples from our area, and just kind of do a broad swath and see what we see, and then figure out, can we move upstream like we expect? We're hoping to be able to start downstream at low level and work our way upstream and find higher levels and identify, oh, there's a cook taking place here. So we'll have to see how that goes. And at the same time, we're trying to move forward on the airborne analysis as well, which is a little bit of a challenge just from a research perspective. But yeah, it's funded, and we're trying to just get through at least to the end of that project. And hopefully the impact will be that we demonstrate that it works. And then from there, won't it be interesting, and I do still have colleagues in the EPA, but it'll be interesting to see how we use the data. Is it going to be something that, law enforcement wants to use to try and track labs, or are we going to just treat it more like a public health epidemiological problem? NIJ, besides the forensic science, NIJ does a lot of social science research in terms of criminal justice and policy, and I learned a little bit about the NIJ. It's a neat organization, and what if what we're doing could help identify where there might be areas that children are being exposed to this, where we can identify crime patterns or things like that based on this work. And then can we do something to change the culture so that that's not taking place? That would be really...
Well, yeah, the NIJ has an excellent drugs and crime research portfolio. One of the things we'll do off of this podcast is link to it so that people can start to educate themselves about it, because it really is very interesting, and it's had an enormous impact on things like drug courts and many other areas to improve how the nation deals with drug abuse and the crime associated with it. I also want to take the opportunity to plug Savannah River, because I'm glad to hear they're involved with you. They've done an awful lot of work for NIJ and for the law enforcement community. Their work just in personal protective equipment and body armor was critical for NIJ during my time when I was there. A lot of great science that comes out of there, so I'm glad to hear that they're part of your work.
Yeah, and they have access to things that they have tools that I don't have available in my lab.
It's a nice SEM. Did they do the X-ray diffraction work for you too?
Yes.
Okay, excellent.
Yeah, so they've been really good colleagues on it, and they're good at managing very large projects. So I love to do the science. Probably not the best project manager. I get wrapped up in what I'm doing, and I want to focus on getting the data and all this stuff, but it's hard to be well organized with it, and you have to be, or else you can't get the information out. And so they've been really helpful in kind of guiding it along as we go to the different checkpoints and make sure that we reach the goals that we have set. I'm looking forward to, as you mentioned, would you use some IR, maybe some LiDAR, are there some standoff detection systems? That is what they do, right? So I'm really looking forward to see what they bring to bear.
And but that's great. So I do think that what you're doing, it's a great example of what we're trying to talk about with the podcast, because you are focused on just the science, right? And the implications of that, whether it's for how law enforcement does investigation or public health, or even understanding the toxicology. There's a million ways that can be relevant, but getting the science right is the first step, right? So that's excellent. Very much
Well,
much
I appreciate you letting me come on the show and talk about the work. And I do want to encourage, I think we'll have links and things like that on there.
Mm-hmm.
And if there are other researchers that have an interest in this, I'd certainly welcome that. And of course, we have an accredited graduate program. So we're a master's institution. So just for a plug for our school, my students work on these projects. And so if that's something, if someone's listening that really wants to do forensic science, we get to do some practical work in my lab in addition to doing research, and then really work hard to make sure that my students get out and get jobs in the field.
Sure. And you actually have an online master's degree for forensic administration, don't you?
Yes, we do. Yeah, that's also a lot of times that's someone that's already in the field, and they want to get better at the management aspects, and they want to advance their career that way. So we do have an administration online degree. With the chemistry, with forensic chemistry track, that's really on campus. The graduates we've had are all ambassadors for our program, so it helps, and we've grown so much. And part of it is, the ability to do research projects like this and to have the equipment, but I need students to help with the projects. And so I appreciate you helping me get the word out about the research and also our program.
Well, it's been great to have you on the program. I think it's been very entertaining for me, and I hope for the audience as well. And I look forward to hearing more from you in the years to come.
Thank you very much.
Thank you, Jarrad.
Next week on Just Science, we will be discussing synthetic cathinoids with Lindsay Glicksberg from Sam Houston University. The Just Science special release season will highlight other speakers from the 2017 NIJ R&D Symposium, including Dr. Rob Mayer, Dr. Jeffrey Wells, and Dr. Lynn Lamott. Opinions or points of views expressed in this podcast represent a consensus of the authors and do not necessarily represent the official position or policies of its funding.